There are lots of things that science can explain pretty well. Why cats always land on their feet, why planes fly, even how life began on Earth. But there's one thing that scientists haven't been able to figure out yet. What if we could teleport? Now, before you click away, let me clarify. Scientists actually do know what would happen if we could teleport, right? They have a good idea, at least. But most of us don't understand the math behind it, which is fair because it involves some very complex physics. But if we were to simplify all those concepts down to a level that a 12-year-old could grasp, you get something like this. In theory, anything that has mass and takes up space can be in two places at once. This is called a superposition, and it's what's happening right now inside your computer screen. Every single pixel is both on and off at the same time. The reason you can see the image of an apple on your screen, though, is because every part of the apple is only in one place at a time. Your brain just interprets information from one part of the apple at a time, not from all parts simultaneously. It's kind of like if you had a friend who was really bad at making decisions, so bad that he could never choose between two restaurants, but would instead always wind up at some random McDonald's halfway between the two. But here's the kicker. If we could somehow measure or observe that pixel or your friend in a way that does unaffect them, then we could know exactly where they are. We already do this sort of thing with light particles called photons. By observing their behavior, we know exactly where they are. So hypothetically, if we could measure every particle that makes up your friend, including his location and momentum, we could send that data somewhere else and instantaneously recreate him there. It'd be like sending yourself an invitation to the party you're already at. It's just the basic principle behind what scientists call quantum teleportation, although it doesn't involve physically moving any matter from one place to another. Instead, it uses entanglement to send the state of one particle to another. But since no physical thing is ever exchanged, nothing moves faster than the speed of light. And since no information is exchanged, technically speaking, nothing is actually being sent at all. That's why the image on your screen is still just ones and zeros, even though you think it looks like a juicy red apple. Information isn't being created or destroyed, it's just being interpreted differently. This is all sounding a bit confusing. Don't worry. Even physicists struggle to wrap their heads around quantum mechanics. The good news is that you do need to understand it at all to appreciate how cool it would be if we could teleport. Imagine you restuck on the other side of the country and you really want to be at home. With traditional technology, the fastest way to get there would be hopping on a plane and enduring 8 hours of turbulence, overpriced snacks, and crying babies. With teleportation, you'd just step into a booth, disappear, and reappear next to your mom in less time than it takes to watch Game of Thrones. And when you left, the booth would automatically make sure that everything that was in your hand ended up in your hand, too. You wouldn't even need to worry about bringing your bags with you. And while teleportation might seem like a relatively benign form of transportation, its implications would extend far beyond just getting you from point A to point B. Take international business, for example. Right now, face-to-face negotiations take a lot of coordination and preparation, not to mention time and money. But if teleportation were possible, executives could simply pop over to Hong Kong for a meeting during their lunch break. Or maybe we'd all grow tired of seeing our homes and spend more time visiting exotic locales like Mars. Teleporting us there would save a ton of time and money. In fact, it could make interplanetary living a lot more feasible. In just under 7 minutes, we could leave the red planet and return to Earth, giving us enough time to finish our colonizing projects without needing to stay there permanently. It also means that the concept of distance itself would change. No longer would we use miles or kilometers to determine how far away something is. Instead, we'd use the amount of time it took to get there, which means that Kansas would be a lot closer to New York City than it is to Los Angeles. On the less utopian end of things, teleportation could also make it easier to sneak around. Imagine going to work tomorrow and finding that someone had replaced you in your job, apartment, and life. Unless you have an identical twin, that person must have used teleportation to completely replace you. But while it would be annoying to come home to a stranger sitting on your couch, it would be a whole lot worse to come home to a dead body. Because if teleportation worked on people, it would also work on microscopic assassins. In other words, it would be easy to teleport tiny bits of poison into your food, making food poisoning a much more common problem. But even if we could solve all of these problems, there's one more thing that we'd have to consider. One of the fundamental principles of quantum mechanics is that we can't know both where something is and where it's going at the same time. If we know where an electron is, we don't know which direction it's moving. And if we know which direction it's moving, we don't know where it is. So we can't know these two things at the same time. It would be impossible to map out every particle in the universe and know exactly where it's going. So when it came time to recreate someone through teleportation, we'd have to guess at the state of some of those particles, okay? And it's likely that those guesses would be wrong. In other words, we'd never be able to perfectly copy another human being. Any attempt at doing so would result in the creation of a unique individual who would go on to live a totally different life. Okay, so teleporting people might not work out, but what about teleporting other stuff like luggage? Maybe it's simpler to first break it down into smaller parts and then reassemble it at the destination. Well, in theory, this would work just fine. You'd disassemble the bag at one end, transmit all the information about its constituent particles to another location, and then reassemble it there. But in practice, there's a much bigger problem. There are trillions of atoms in the observable universe, and each one moves in a slightly different direction. As time goes on, the number of possible locations that they could occupy grows exponentially. Eventually, there would be more possible locations for the particles to be in than actual locations in the universe. So trying to find all of those particles at their exact starting points would be like finding a needle in a haystack, except the needle is made of protons and neutrons and electrons, and the haystack is infinite. But while we might never perfect the art of teleportation, we're already taking steps toward making it a reality. Scientists at the University of Basel in Switzerland recently teleported a single photon from one end of the campus to the other, 900 meters away. While that might not sound particularly impressive, it was the first time anyone had ever teleported light without using fiber optics or free space. So the researchers are pretty excited about it, and who knows, maybe one day soon we'll be able to teleport all the way from Switzerland to Scotland. Just don't expect us to arrive at exactly the same time, thanks to relativity. We'd probably arrive 25 years in the past and have to fight off Queen Elizabeth I to get back to the present. Oh, maybe by then someone will have invented time machines and we won't need teleportation at all. If you want to learn more about how the science of today might become the science fiction of tomorrow, you'll love Brilliant's course on quantum computing. It explains how computers use quantum physics to store information and perform calculations in ways that would have seemed impossible to our 1950s conception of computers. In just 5 fun lessons, you'll learn all about the different types of qubits that hold quantum information, how to manipulate them with logic gates, and how to use entanglement to outperform any classical computer. And unlike our hypothetical teleportation booths, you can access Brilliant from anywhere in the world.